Hello and welcome back to XGENIA tutorial. Today we're going to finish our chatbot. Alright, let's debug the current state of our chatbot build. We have the visual flow set up, but the initial handshake in the simulator is failing. We aren't getting a return payload from the model yet. It looks like the request is going out, but the response handling is swallowing the data. We suspect the issue lies within our custom JavaScript logic inside the API connection node. Let's crack open the script editor and take a look. We are using a standard JavaScript asynchronous fetch request. We construct our payload with the model ID and the message history. Notice how we are passing the authorization headers securely using the API key variable we defined earlier. It looks like the request is going out, but the response handling is swallowing the data. We suspect the issue lies within our custom JavaScript logic inside the API connection node. Let's crack open the script editor and take a look. Here's the culprit. We were pointing to the wrong object key in the JSON response. We forgot to add S in this line, a simple syntax error but could ruin our program. Let's just fix it. Script saved. Let's check our node inputs and outputs. They look consistent. The logic flow passes the user message into our script and expects a string output for the UI updater. Let's rerun the integration test, sending the greeting, and perfect. The response text is rendering. It was indeed a malformed path in our API endpoint logic. Now that the logic layer is stable, let's look at the presentation layer. We need to ensure our component hierarchy is set up to handle dynamic content lengths. Let's ask for a definition to trigger a long-form response. Here is a common UI regression. You see that the text container is clipping the content. We need it to expand to fit the text body. We need to adjust the layout constraints. Our container is currently set to a fixed height, which is preventing the overflow from displaying. Let's check on the group text input. It seems like we don't need to change anything here, so just undo it. We need to go to group chat and check for clip content and enable scroll. Just tick both of them. This would make the UI even better as you can scroll down your conversation with the chatbot. Don't forget to check the AI answer node and tick the clip content. We're also removing the hard-coded pixel height on the chat bubble components. By setting the vertical layout to automatic or fill, we allow the bubble to expand based on the token count of the response. Let's adjust the group chat node to make the UI even better. We need to adjust the scrolling experience for the user of this chatbot. One last tweak on the main scroll view. We need to ensure the scroll bounds react to the content size change dynamically. That's why we tick the Show Scroll Bar in the group chat. Okay, stress test time. Let's ask for the history of World War II. This should return a massive block of text, which will verify if our wrapping and scrolling logic is holding up. Response received. The text is wrapping correctly, the container expanded, and the scroll functionality is smooth. The UI is now responsive to variable payload sizes. But we need to refine the backend logic to control how the AI formats its answers. Let's edit the height in the group chat to 80. It makes the content full but still scrollable. Switching to the node graph, we'll locate our primary string node. This will serve as our system prompt, acting as the foundational instruction set for the language model. We are hard-coding a specific constraint here. We are explicitly telling the model Do not use markdown or special characters for bold text, answer quickly, and maintain efficiency. This ensures our output remains clean and parses correctly on the front end. Now, we establish the data flow. We'll connect the output of our string node directly to the system prompt input of our main logic function. This injects our behavior rules into the request payload. Let's perform a quick integration test. We'll send a query to verify that the function node is correctly processing the new system prompt we just wired up. Back in the graph, we can inspect the node's output data. It's crucial to verify that our prompt is being passed correctly within the JSON object before we move on to UI polish. To test it out now, connect the click output from the send button to run input from the API connection node. Then see what happened here. Alright, it works fine for now. With the logic handled, let's shift our focus to the UI UX. We need to update the visual hierarchy and branding of the chat window. Seems like we need to delete the connection we've made before we continue. Let's update the copy. We'll experiment with the naming convention here, eventually settling on XGENIA Chatbot to align with our project branding. Alright, the name is set. To improve readability and visual weight, we are going to modify the typography styles. We'll switch the font family to Arial Black. This gives the header a stronger presence in the UI. We are currently stress testing the conversation flow. We can see that standard queries work, but when we attempt to chain commands or modify the input rapidly, we trigger a runtime exception. The error log indicates an undefined system prompt variable. Let's debug the backend logic. Opening the API connection node, we can see the JavaScript request body. It appears we failed to include the system prompt in the message array construction. This is a critical omission for the LLM's context. We are patching the payload now by explicitly mapping the system prompt variable to the content key. This ensures the model receives the correct initialization instructions. Let's recompile and send a test string to verify the fix. It's fixed now. The API response is now stable. However, we have identified a significant UX friction point. Notice that the input field does not auto-clear after submission. We need to implement an automated clear function. We are tracing the event listeners attached to the send trigger. We need to ensure the state update for the text field happens after the message is dispatched. Now, try to connect the click output on the send button to the clear output on the user message. It doesn't work well anyway. To handle this, we will introduce a delay node into the execution chain. This acts as a buffer. Then set the duration to 500 and connect the send button to it. Choose click output and restart input. Now pass the data from delay node by choosing finished output to clear input in the user message. Next, we try to interact with the chatbot again, just to test it out. We can see the delay we've set is working properly, and the chatbot responds accordingly. As a best practice for maintainability, we are renaming this node to delay for clear messages. Clear documentation within the visual graph is essential for scaling the project. Now, let's test the content retrieval. Here is where it gets interesting. We need to try to ask something random. The response is valid, but the data formatting needs adjustment. We are entering the repeater node, which serves as our local data source. We need to ensure the content assistant key is populating correctly with the rich text data we expect. We are updating the mock database with a more complex string, specifically the immortal jellyfish fact. This tests how our text rendering component handles longer paragraphs and line wrapping within the chat bubble. The data binding is working perfectly. Now we shift our focus to the UI. The current visual hierarchy is weak. The sender names are blending in with the message body. We need to establish better contrast. Time to be creative. Let's change the display name of the chatbot into AI Assistant and depict the user as you. We are selecting the text components for both the AI and user labels. We will update the typography from the standard weight to Roboto Bold. This simple change creates a clear visual distinction between the metadata and the actual conversation content. The updated typography improves the scannability of the chat log significantly. The interface is now functionally robust with the bug fixes and visually cleaner with the updated styles. Congratulations, our AI chatbot is running functionally. What else do you want to learn? Comment down below. Thanks for watching. Get XGENIA for free today at xgenia.ai and start building smarter and faster than ever.